Chapter 2: Acids, Bases and Salts. You have learnt in your previous classes that the sour and bitter tastes of food are due to acids and bases, respectively, present in them. If someone in the family is suffering from a problem of acidity after overeating, which of the following would you suggest as a remedy? Lemon juice, vinegar, or baking soda solution? Which property did you think of while choosing the remedy? Surely you must have used your knowledge about the ability of acids and bases to nullify each other's effect. Recall how we tested sour and bitter substances without tasting them. You already know that acids are sour in taste and change the color of blue litmus to red, whereas bases are bitter and change the color of the red litmus to blue. Litmus is a natural indicator. Turmeric is another such indicator. Have you noticed that a stain of curry on a white cloth becomes reddish brown when soap, which is basic in nature, is scrubbed on it? It turns yellow again when the cloth is washed with plenty of water. You can also use synthetic indicators such as methyl orange and phenolphthalein to test for acids and bases. In this chapter, we will study the reactions of acids and bases, how acids and bases cancel out each other's effect, and many more interesting things that we use and see in our day-to-day life. Do you know? Litmus solution is a purple dye which is extracted from lichen, a plant belonging to the division Thallophyta, and is commonly used as an indicator when the litmus solution is neither acidic nor basic. Its color is purple. There are many other natural materials like red cabbage leaves, turmeric, colored petals of some flowers such as hydrangea, petunia, and geranium, which indicate the presence of acids or base in a solution. These are called acid-base indicators or sometimes simply indicators. Questions? Do this and comment this. Understanding the chemical properties of acids and bases. Acids and bases in the laboratory. Activity 2.1. Collect the following solution from the science laboratory: hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3, acetic acid CH3COOH, sodium hydroxide NaOH, calcium hydroxide CaOH2, potassium hydroxide KOH, magnesium hydroxide MgOH2, and ammonium hydroxide NH4OH. Put a drop of each of the above solution on a watch glass one by one and test with a drop of indicators shown in table. What change in color did you observe with red litmus, blue litmus, phenolphthalein, and methyl orange solutions for each of the solution taken? Tabulate your observations in table. Comment this. Table: simple solution, red litmus solution, blue litmus solution, phenolphthalein solution, methyl orange solution. These indicators tell us whether a substance is acidic or basic by change in color. There are some substances whose order changes in acidic or basic medium. These are called olfactory indicators. Let us try out some of these indicators. Activity: take some finely chopped onions in plastic bag, along with some strips of clean cloth. Tie up the bag tightly and leave overnight in the fridge. The cloth strips can now be used to test for acids and bases. Take two of these cloth strips and check their order. Keep them on a clean surface and put a few drops of dilute HCl solution on one strip and few drops of dilute NaOH solution on the other. Rinse both cloth strips with water and again check their order. Note your observation. Now take some dilute vanilla essence and clove oil and check their order. Take some dilute HCl solution in one test tube and dilute NaOH solution in another. Add a few drops of dilute vanilla essence to both test tubes and shake well. Check the order once again and record changes in order, if any. Similarly, test the change in the order of clove oil with dilute HCl and dilute NaOH solutions and record your observations. Which of these, vanilla, onion, and clove, can be used as olfactory indicators on the basis of your observations? Let us do some more activities to understand the chemical properties of acids and bases. How do acids and bases react with metals? Activity. Caution. This activity needs the teacher's assistant. Set the apparatus as shown in figure. Take about 5 ml of dilute sulfuric acid in a test tube and add a few pieces of zinc granules to it. What do you observe on the surface of zinc granules? Pass the gas being evolved through the soup solution. Why a bubble formed in the soup solution? Take a burning candle near a gas-filled bubble. What do you observe? Repeat this activity with some more acids like HCl, HNO3 and CH3COOH. Are the observations in all the cases the same or different? Comment this. Figure reaction of zinc granules with dilute sulfuric acid and testing hydrogen gas by burning. Stand, test tube, dilute sulfuric acid, zinc granules, hydrogen gas bubbles. Delivery tube, a soap solution, soap bubble filled with hydrogen. Burning of hydrogen gas with a pop sound, candle. Note that the metal in the above reactions displaces hydrogen atoms from the acids as hydrogen gas and forms a compound called a salt. Thus, the reaction of a metal with an acid can be summarized as acid plus metal tends to salt plus hydrogen gas. Can you now write the equations for the reaction you have observed? Comment this. Activity. Place a few pieces of granulated zinc metal in a test tube and 2 ml of sodium hydroxide solution and warm the contents of the test tubes. Repeat the test of the steps as in activity and record your observation. Comment this. The reaction that takes place can be written as follows: 2 NaOH aqueous plus zinc solid tends to Na2ZnO2 solid plus H2 gas sodium zincate. You find again that hydrogen is formed in the reaction. However, such reactions are not possible with all metals. How do metal carbonates and metal hydrocarbonates react with acids? Activity. Take two test tubes, label them as A and B. Take about 0.5 gram of sodium carbonate Na2CO3 in test tube A and about 0.5 gram of sodium hydrogen carbonate NaHCO3 in test tube B. Add about 2 ml of dilute HCl to both the test tubes. What do you observe? Pass the gas produced in each case through lime water, calcium hydroxide solution as shown in figure and record your observation. Figure passing carbon dioxide gas through calcium hydroxide solution. Thistle funnel, stand, cork, carbon dioxide gas, dilute hydrochloric acid. A. Test tube, sodium carbonate, calcium hydroxide solution, delivery tube, test tube. The reactions occurring in the above activities are written as test tube A. Na2CO3 is solid plus 2HCl aqueous tends to 2NaCl aqueous plus H2O liquid plus CO2 gas. Test tube B. NaHCO3 solid plus HCl aqueous tends to NaCl aqueous plus H2O liquid plus CO2 gas. On passing, the carbon dioxide gas evolved through lime water. CaOH2 aqueous plus CO2 gas lime water tends to CaCO3 solid white precipitate plus H2O liquid. On passing excess carbon dioxide, the following reaction takes place: CaCO3 solid plus H2O liquid plus CO2 gas tends to CaHCO3 aqueous soluble in water. Limestone, chalk and marble are different forms of calcium carbonate. All metal carbonates and hydrogen carbonates react with acids to give a corresponding salt, carbon dioxide and water. Thus, the reaction can be summarized as metal carbonate or metal hydrogen carbonate plus acid tends to salt plus carbon dioxide plus water. How do acids and bases react with each other? Activity. Take about 2 ml of dilute NaOH solution in a test tube and add 2 drops of phenolphthalein solution. What is the color of the solution? Add dilute HCl solution to the above solution drop by drop. Is there any color change for the reaction mixture? Why did the color of phenolphthalein change after the addition of an acid? Now add a few drops of NaOH to the above mixture. Does the pink color of phenolphthalein reappear? Why do you think this has happened? Comment this. In the above activity, we have observed that the effect of a base is nullified by an acid and vice versa. The reaction taking place is written as NaOH aqueous plus HCl aqueous tends to NaCl aqueous plus H2O liquid. The reaction between an acid and bases to give a salt and water is known as a neutralization reaction. In general, a neutralization reaction can be written as base plus acid tends to salt plus water. Reaction of metallic oxides with acids. Activity. Take a small amount of copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. Note the color of the solution. What has happened to the copper oxide? Comment this. You will notice that the color of the solution becomes blue-green and copper oxide dissolves. The blue-green color of the solution is due to the formation of copper 2 chloride in the reaction. The general reaction between a metal oxide and an acid can be written as metal oxide plus acid tends to salt plus water. Now write and balance the equation for the above reaction. Since metallic oxides react with acids to give salts and water, similar to the reaction of a base with an acid, metallic oxides are said to be basic oxides. Reaction of a non-metallic oxide with base. You saw the reaction between carbon dioxide and calcium hydroxide lime water in activity. Calcium hydroxide, which is a base, reacts with carbon dioxide to produce a salt and water. Since this is similar to the reaction between a base and an acid, we can conclude that non-metallic oxides are acidic in nature. Questions? Do this and comment this. What do all acids and all bases have in common? In section, we have seen that all acids have similar chemical properties. What leads to this similarity in properties? We saw in activity that all acids generate hydrogen gas when reacting with metals. So, hydrogen seems to be common to all acids. Let us perform an activity to investigate whether all compounds containing hydrogen are acidic. Activity: take solution of glucose, alcohol, hydrochloric acid, sulfuric acid, etc. Fix two nails on a cork and place the cork in a 100 milliliter beaker. Connect the nails to the two terminals of a 6-volt battery through a bulb and a switch as shown in figure. Now pour some dilute HCl in the beaker and switch on the current. Repeat with dilute sulfuric acid. What do you observe? Repeat the experiment separately with glucose and alcohol solutions. What do you observe now? Does the bulb glow in all cases? Comment this. Figure: acid solution in water conduct electricity. 6-volt battery, bulb, switch, beaker, nail, dilute HCl solution, rubber cork. The bulb will start glowing in the case of acids as shown in figure, but you will observe that glucose and alcohol solutions do not conduct electricity. Glowing of the bulb indicates that there is a flow of electric current through the solution. The electric current is carried through the acidic solution by ions. Acids contains H plus ions as cation and anions such as Cl minus in HCl. NO3 minus in HNO3, SO4, 2 minus in H2SO4, CH3COO minus in CH3COOH. Since the cation present in acids is H plus, this suggests that acids produce hydrogen ions H plus aqueous in solution, which are responsible for their acidic properties. Repeat the same activity using alkalis such as sodium hydroxide, calcium hydroxide, etc. What can you conclude from the results of this activity? Comment this. What happens to an acid or base in a water solution? Do acids produce ions only in aqueous solution? Let us test this. Activity: take about 1 gram solid NaCl in a clean and dry test tube and set up the apparatus as shown in figure. Add some concentrated sulfuric acid to the test tube. What do you observe? Is there a gas coming out of the delivery tube? Test the gas evolved successively with dry and wet blue litmus paper. In which case does the litmus paper change color? On the basis of the above activity, what do you infer about the acidic character of 1. Dry HCl gas, 2. HCl solution? Comment this. Note to teachers: if the climate is very humid, you will have to pass the gas produced through a guard tube, drying tube containing calcium chloride to dry the gas. Preparation of HCl gas: dropper containing concentrated H2SO4, a pair of tongues, test tube, sodium chloride, most litmus paper, delivery tube, cork, test tube, a pair of tongues, guard tube containing calcium chloride. This experiment suggests that hydrogen ions in HCl are produced in the presence of water. The separation of H plus ion from HCl molecules cannot occur in the absence of water. HCl plus H2O tends to H3O plus Cl minus. Hydrogen ions cannot exist alone, but they exist after combining with water molecule. Thus, hydrogen ions must always be shown as H plus aqueous or hydronium ion H3O plus. H plus H2O tends to H3O plus. We have seen that acids give H3O plus or H plus aqueous ion in water. Let us see what happens when a base is dissolved in water. NaOH solid tends to with H2O, Na plus aqueous plus waste minus aqueous. KOH solid H2O tends to K plus aqueous plus minus aqueous, MgOH whole 2 solid with H2O tends to Mg2 plus aqueous plus 2OH minus aqueous. Bases generate hydroxide OH minus ions in water. Bases which are soluble in water are called alkalis. Do you know? All bases do not dissolve in water. An alkali is a base that dissolves in water. They are soapy to touch, bitter and corrosive. Never taste or touch them as they may cause harm. Which of the bases in the table are alkalis? Comment this. Now, as we have identified that all acids generate H plus aqueous and all bases generate OH minus aqueous, we can view the neutralization reaction as follows. Acid plus base tends to salt plus water. H X plus M OH tends to MX plus HOH. H plus aqueous plus OH minus aqueous tends to H2O liquid. Let us see what is involved when water is mixed with an acid or a base. Activity. Take 10 milliliter water in a beaker, add a few drops of concentrated H2SO4 to it and swirl the beaker slowly. Touch the base of the beaker. Is there a change in temperature? Is this an exothermic or endothermic process? Repeat the above activity with sodium hydroxide pellets and record your observations. Figure. Warning sign displayed on containers containing concentrated acids and bases. The process of dissolving an acid or a base in water is a highly exothermic one. Care must be taken while mixing concentrated nitric acid or sulfuric acid with the water. The acid must always be added slowly to water with constant stirring. If water is added to a concentrated acid, the heat generated may cause the mixture to splash out and cause burns. The glass containers may also break due to excessive local heating. Look out for the warning sign shown in figure on the can of concentrated sulfuric acid and on the bottle of sodium hydroxide pellets. Mixing an acid or base with water results in decrease in the concentration of ions H3O plus or H minus per unit volume. Such a process is called dilution and the acid or the base is said to be diluted. Questions? Do this and comment this. How strong are acid or base solutions? We know how acid-base indicators can be used to distinguish between an acid as a base. We have also learned in the previous section about dilution and decrease in concentration of H plus or H minus ion in solution. Can we quantitatively find the amount of these ions present in a solution? Can we judge how strong a given acid or base is? We can do this by making use of a universal indicator, which is a mixture of several indicators. The universal indicator shows different colors at different concentrations of hydrogen ions in a solution. A scale for measuring hydrogen ion concentration in a solution called pH scale has been developed. The P in pH stands for Potenz in German, meaning power. On the pH scale, we can measure pH generally from 0 very acidic to 14 very alkaline. pH should be thought of simply as a number which indicates the acidic or basic nature of a solution. Higher the hydronium ion concentration, lower is the pH value. The pH of a neutral solution is 7. Values less than 7 on the pH scale represent an acidic solution. As the pH values increase from 7 to 14, it represents an increase in H minus ion concentration in the solution. That is increase in the strength of alkali. Figure generally paper impregnated with the universal indicator is used for measuring pH. Figure: variation of pH with the change in concentration of H plus aqueous and H minus aqueous ions. Acidic nature increasing, basic nature increasing, neutral 7, 0, 14. H plus, H minus, increase in H plus ion concentration, decrease in H plus ion concentration. Activity: test the pH values of solution given in table. Record your observation. What is the nature of each substance on the basis of your observations? Comment this. Table: serial number 1, solution, color of pH paper, approximate pH value, nature of substance. 1. Saliva before meal. 2. Saliva after meal. 3. Lemon juice. 4. Colorless aerated drink. 5. Carrot juice. 6. Coffee. 7. Tomato juice. 8. Tap water. 9. 1 ml NaOH. 10. 1 ml HCl. Figure: pH of some common substances shown on the pH paper. Colors are only a rough guide. 0. 1 gastric juice about 1.2, 2 lemon juice about 2.2, 3, 4, 5, 6, 7 pure water, blood 7.4, 8, 9, 10 milk of magnesia 10, 11, 12, 13, 14 sodium hydroxide solution about 14. The strength of acid and bases depends on the number of H plus ions and H minus ions produced respectively. If we take hydrochloric acid and acetic acid of the same concentration, say 1 molar, then these produce different amounts of hydrogen ions. Acids that give rise to more H plus ions are said to be strong acids, and acids that give less H plus ions are said to be weak acids. Can you now say what weak and strong bases are? Comment this. Importance of pH in everyday life. Are plants and animals pH sensitive? Our body works within the pH range of 7.0 to 7.8. Living organisms can survive only in a narrow range of pH change. When pH of rainwater is less than 5.6, it is called acid rain. When acid rain flows into the rivers, it lowers the pH of the river water. The survival of aquatic life in such rivers becomes difficult. Do you know acids in other planets? The atmosphere of Venus is made up of thick white and yellowish clouds of sulfuric acid. Do you think life can exist on this planet? Comment this. What is the pH of the soil in your backyard? Plants require a specific pH range for their healthy growth. To find out the pH required for the healthy growth of a plant, you can collect the soil from various places and check the pH in the manner described below in activity. Also, you can note down which plants are growing in the regions from which you have collected the soil. Activity: put about 2 grams soil in a test tube and add 5 ml water to it. Check the contents of the test tube. Filter the contents and collect the filtrate in the test tube. Check the pH of this filtrate with the help of universal indicator paper. What can you conclude about the ideal soil pH for the growth of plants in your region? Comment this. pH in our digestive system. It is very interesting to note that our stomach produces hydrochloric acid. It helps in the digestion of food without harming the stomach. During indigestion, the stomach produces too much acid, and this causes pain and irritation. To get rid of this pain, people use bases called antacids. One such remedy must have been suggested by you at the beginning of this chapter. These antacids neutralize the excess acid. Magnesium hydroxide, milk of magnesia, a mild base, is often used for this purpose. pH change as the cause of tooth decay. Tooth decay starts when the pH of the mouth is lower than 5.5. Tooth enamel, made up of calcium hydroxyapatite, a crystalline form of calcium phosphate, is the hardest substance in the body. It does not dissolve in water but is corroded when the pH in the mouth is below 5.5. Bacteria present in the mouth produce acids by degradation of sugar and food particles remaining in the mouth after eating. The best way to prevent this is to clean the mouth after eating food using toothpaste, which are generally basic. For cleaning, the teeth can neutralize the excess acids and prevent tooth decay. Self-defense by animals and plants through chemical warfare. Have you ever been stung by a honeybee? Bee sting leaves an acid which causes pain and irritation. Use of a mild base like baking soda on the stung areas gives relief. A stinging hair of nettle leaves inject methanoic acid causing burning pain. Do you know? Nature provides neutralization options. Nettle is a herbaceous plant which grows in the wild. Its leaves have stinging hair, which cause painful sting when touched accidentally. This is due to the methanoic acid secreted by them. A traditional remedy is rubbing the area with the leaf of the dock plant, which often grows beside the nettle in the wild. Can you guess the nature of the dock plants? So next time you know what to look out for if you accidentally touch a nettle plant while trekking. Are you aware of any other effective traditional remedies for such stings? Comment this. Some naturally occurring acids. Natural source, vinegar, orange, tamarind, tomato. Acid, acetic acid, citric acid, tartaric acid, oxalic acid. Natural source, acids, sour, milk curd, lactic acid, lemon, citric acid, ant sting, methanoic acid, nettle sting, methanoic acid. Questions? Do this and comment this. More about salts. In the previous section, we have seen the formation of salts during various reactions. Let us understand more about their preparation, properties, and uses. Family of salts. Activity. Write the chemical formula of the salts given below. Potassium sulfate, sodium sulfate, calcium sulfate, magnesium sulfate, copper sulfate, sodium chloride, sodium nitrate, sodium carbonate, and ammonium chloride. Identify the acids and bases from which the above salts may be obtained. Salts having the same positive or negative radicals are said to belong to the family. For example, NaCl and Na2SO4 belong to the family of sodium salts. Similarly, NaCl and KCl belong to the family of chloride salts. How many families can you identify among the salts given in the activity? Comment this. pH of salts. Activity. Collect the following salt samples: sodium chloride, potassium nitrate, aluminum chloride, zinc sulfate, copper sulfate, sodium acetate, sodium carbonate, and sodium hydrogen carbonate. Some other salts available can also be taken. Check their solubility in water. Use distilled water only. Check the action of these solutions on litmus and find the pH using a pH paper. Which of the salts are acidic, basic, or natural? Identify the acid or base used to form the salt. Report your observation in table. Comment this. Salt of a strong acid and a strong base and neutral with pH value of 7. On the other hand, salts of a strong acids and weak base are acidic with pH values less than 7, and those of a strong base and weak acid are basic in nature in pH value more than 7. Table: salt, pH, acid used, base used. Comment this. Chemical from common salt. By now, you have learned that the salt formed by the combination of hydrochloric acid and sodium hydroxide solution is called sodium chloride. This is the salt that you use in food. You must have observed in the above activity that it is a natural salt. Seawater contains many salts dissolved in it. Sodium chloride is separated from these salts. Deposits of solid salts are also found in several parts of the world. These large crystals are often brown due to impurities. This is called rock salt. Beds of rock salt were formed when seas of bygone ages dried up. Rock salt is mined like coal. You must have heard about Mahatma Gandhi's Dandi March. Did you know that sodium chloride was such an important symbol in our struggle for freedom? Comment this. Common salt, a raw material for chemicals. The common salt thus obtained is an important raw material for various materials of daily use such as sodium hydroxide, baking soda, washing soda, bleaching powder, and many more. Let us see how one substance is used for making all these different substances. Sodium hydroxide. When electricity is passed through an aqueous solution of sodium chloride called brine, it decomposes to form sodium hydroxide. The process is called the Chlor-alkali process because of the products formed: chlor for chlorine and alkali for sodium hydroxide. 2NaCl aqueous plus 2H2 liquid tends to 2NaOH aqueous plus Cl2 gas plus H2 gas. Chlorine gas is given off at the anode and hydrogen gas at the cathode. Sodium hydroxide solution is formed near the cathode. The three products produced in this process are all useful. Figure shows the different uses of these products. Figure: important products from the chlor-alkali process. Water treatment, swimming pools, PVC, disinfectants, CFCs, pesticides. Brine, Cl2, anode, cathode, H2, fuels, margarine, ammonia for fertilizers, brine containing NaOH, degreasing metals, soaps and detergents, paper making, artificial fibers, Cl minus, OH minus, Na plus, H plus, membrane. Bleaching powder. You have already come to know that chlorine is produced during the electrolysis of aqueous solution chloride, brine. This chlorine gas is used for the manufacture of bleaching powder. Bleaching powder is produced by the action of chlorine on dry flaked lime CaOH2. Bleaching powder is represented as CaOCl2, though the actual composition is quite complex. CaOH2 plus Cl2 tends to CaOCl2 plus H2O. Bleaching powder is used: 1. For bleaching cotton and linen in the textile industry, for bleaching wood pulp in paper factories, for bleaching washed cloth in laundry. 2. As an oxidizing agent in many chemical industries, and 3. to make drinking water free from germs. Baking soda. The baking soda is commonly used in the kitchen for making tasty, crispy pakoras, etc. Sometimes it is added for faster cooking. The chemical name for the compound is sodium hydrogen carbonate NaHCO3. It is produced using sodium chloride as one of the raw materials. NaCl plus H2O plus CO2 plus NH3 tends to NH4Cl, ammonium chloride plus NaHCO3, sodium hydrogen carbonate. Did you check the pH of sodium hydrogen carbonate in activity? Can you correlate why it can be used to neutralize an acid? It is a mild non-corrosive basic salt. The following reaction takes place when it is heated during cooking. 2NaHCO3, sodium hydrogen carbonate, heat Na2CO3, sodium carbonate plus H2O plus CO2. Sodium hydrogen carbonate has got various uses in the household. Uses of baking soda. 1. For making baking soda powder. For making baking powder, which is a mixture of baking soda, sodium hydrogen carbonate and a mild edible acid such as tartaric acid, when baking powder is heated or mixed in water, the following reaction takes place. NaHCO3 plus H plus from any acid tends to CO2 plus H2O plus sodium salt of acid. Carbon dioxide produced during the reaction can cause bread or cake to rise, making them soft and spongy. 2. Sodium hydrogen carbonate is also an ingredient in antacid. Being alkaline, it neutralizes excessive acid in the stomach and provides relief. 3. It is also used in soda acid fire extinguishers. Washing soda. Another chemical that can be obtained from sodium chloride is Na2CO3 10H2O, washing soda. You have seen above that sodium carbonate can be obtained by heating baking soda. Recrystallization of sodium carbonate gives washing soda. It is also a basic salt. Na2CO3 sodium carbonate plus 10H2O tends to Na2CO3 10H2O. What does 10H2O signify? Does it make Na2CO3 wet? We will address this question in the next section. Sodium carbonate and sodium hydrogen carbonate are useful chemicals for many industrial processes as well. Uses of washing soda. 1. Sodium carbonate washing soda is used in glass, soap and paper industries. 2. It is used in the manufacture of sodium compounds such as borax. 3. Sodium carbonate can be used as a cleaning agent for domestic purposes. 4. It is used for removing permanent hardness of water. Are the crystals of salts really dry? Activity. Heat a few crystals of copper sulfate in a dry boiling tube. What is the color of the copper sulfate after heating? Do you notice water droplets in the boiling tube? Where have these come from? Add 2 to 3 drops of water on the sample of copper sulfate obtained after heating. What do you observe? Is the blue color of copper sulfate restored? Comment this. Figure removing water of crystallization. Burner, a pair of tongues, boiling tube, water droplets, copper sulfate crystals. Copper sulfate crystals which seem to be dry contains water of crystallization. When we heat the crystal, this water is removed and the salt turns white. If you moisten the crystals again with water, you will find that blue color of the crystals reappears. Water of the crystallization is the fixed number of water molecules present in one formula unit of a salt. 5 water molecules are present in one formula unit of copper sulfate. Chemical formula for hydrated copper sulfate is CuSO4 5H2O. And now you would be able to answer the question whether the molecule of Na2CO3 10H2O is wet. One other salt which processes water of crystallization is gypsum. It has two water molecules as water of crystallization. It has the chemical formula CaSO4 2H2O. Let us look into the use of this salt. Plaster of Paris. On heating gypsum at 373 Kelvin, it loses water molecules and becomes calcium sulfate hemihydrate CaSO4 1 by 2H2O. This is called plaster of Paris. The substances which doctors use as plaster for supporting fractured bones in the right position. Plaster of Paris is a white powder, and on mixing with the water it changes to gypsum, once again giving a hard solid mass. CaSO4 half H2O plus 1 and half H2O tends to CaSO4 2H2O, gypsum, plaster of Paris. Note that only half a water molecule is shown to be attached as water of crystallization. How can you get half a water molecule? It is written in this form because two formula units of CaSO4 share one molecule of water. Plaster of Paris is used for making toys, materials for decoration, and for making surfaces smooth. Try to find out why is calcium sulfate hemihydrate called plaster of Paris. Comment this. Questions? Do this and comment this. What you have learned? Acid-base indicator are dyes or mixtures of dyes which are used to indicate the presence of acids and bases. Acidic nature of substances is due to the formation of H plus aqueous ions in solution. Formation of OH minus aqueous ions in solution is responsible for the basic nature of a substance. When an acid reacts with a metal, hydrogen gas is evolved and a corresponding salt is formed. When a base reacts with a metal, along with the evolution of hydrogen gas, a salt is formed which has a negative ion composed of the metal and oxygen. When an acid reacts with a metal carbonate or metal hydrogen carbonate, it gives the corresponding salt, carbon dioxide gas and water. Acidic and basic solutions in water conduct electricity because they produce hydrogen and hydroxide ions respectively. The strength of an acid or an alkali can be tested by using a scale called the pH scale 0 to 14, which gives the measures of hydrogen ion concentration in a solution. A natural solution has a pH of exactly 7, while an acidic solution has a pH less than 7 and a basic solution a pH more than 7. Living beings carry out their metabolic activities within an optimal pH range. Mixing concentrated acids or bases with water is a highly exothermic process. Acids and bases neutralize each other to form corresponding salts and water. Water of crystallization is the fixed number of water molecules present in one formula unit of a salt. Salts have various uses in everyday life and in industries. Exercises. Do this and comment this. Group activity. Do this and comment this. Prepare your own indicator. Crush beetroot in a mortar and sufficient water to obtain the extract. Filter the extract by the procedure learned by you in earlier classes. Collect the filtrate to test the substances you may have tested earlier. Arrange 4 test tubes in a test tube and stand and label them as A, B, C and D. Pour 2 ml each of lemon juice solution, soda water, vinegar and baking soda solution in them respectively. Put 2 to 3 drops of the beetroot extract in each test tube and note the color change if any. Write your observation in a table. You can prepare indicators by using other natural materials like extract of red cabbage leaves, colored petals of some flowers such as petunia, hydrangea, and geranium. 2. Preparing a soda acid fire extinguisher. The reaction of acid with metal hydrogen carbonate is used in the fire extinguisher, which produce carbon dioxide. Take 20 milliliter of sodium hydrogen carbonate NaHCO3 sodium in a wash bottle. Suspend an ignition tube containing dilute sulfuric acid in the wash bottle. Figure: close the mouth of wash bottle, tilt the wash bottle so that the acid from the ignition tube mixed with the sodium hydrogen carbonate solution below. You will notice discharge coming out of the nozzle. Direct this discharge on a burning candle. What happens? Comment this. Figure: a ignition tube containing dilute sulfuric acid suspended in a wash bottle containing sodium hydrogen carbonate. Thread, wash bottle, ignition tube, dilute sulfuric acid, sodium hydrogen carbonate. B. Discharge coming out of the nozzle. Nozzle, discharge coming out. Do this and comment this.